other shim, and it does a lot more. It can load virtually every kind of JavaScript module. A common JS module, written for Node, ECMAScript 6 modules, and universal JavaScript modules. And it works with both Trasur and Babel if you want to use the Transpiling. On top of that, they built JSPM, that is a package manager for the System.js module loader that helps you a lot in setting up your project and gives you a lot of machinery to work better with that. Why we choose System.js? Basically, because it's unopinionated. The technical solution we choose for this application was it has to be unopinionated, because we're not building a classic web application. We're building a desktop application. So we need tools that are not made with classical front-end development workflow in mind. It's not a client tool. It can load every single type of bundle. You can load Node modules that has a native part with that without problems. It doesn't do anything about that. Browserify, for example, try to shim some of the core function of Node, but we have Node inside Electron, so we don't want that, and that's it. It has a super cool feature. You can understand dependencies tree, so you are writing your code, you're writing your import, and actually not System.js and the bundler can understand the dependency tree of your modules of your app, and you can simply build it saying, oh, that's the entry point, that's the main script, let's build me the dependency tree of the whole app. And you can do that, and you can load that dynamically on the browser, on the fly. You can download it on the fly. It has dependency versioning done right, not like NPM. Dependency versioning in NPM is not deterministic, so if you don't use something to save the actual version you have on your machine, you have totally erratic and different version on every build machine you do NPM install, because that's the version fork bombing. Every package can have a dependence, and the second level dependence can have I want any version of that. So if I have that in cache, I get the version 1.0. If a friend of mine, worker, doesn't have that version in cache, you get the 1.01. So you don't know what you are going to push in production. This one does a flattening of dependency tree, and you have versioned on your code repository, so it's very well done. It can do client-side transpiling. You don't have to have a watcher, especially in the first phase of the project. You don't have to set up watcher, gulp script. It just works. It has a shim, a polyfill that you put on the client, and it does automatically the transpiling on the client. Keep an eye on performance here, because when your project grows, the number of files grows. You have a lot of HTTP requests to your single files, and you're gonna hit some performance problem, but you can overcome that passing to a proper build system. But it was good for us, because in 2 minutes we could set up our project without too many problems, and then we dealt with performance problems when they went out. As an a very advanced bundler for production. It has built-in transpiling, as I said, minification, and bundle arithmetic. Bundle arithmetic is something very cool. You can decide to bundle different subtrees of your application. So you can say, that's my app main. So build app main, and it's going to fetch all the application, minus app vendor, that is another bundle tree. You can do something like that. And it works very well. JSPM gives you, it's the CLI tool, that give you an easy way to init your ECMAScript environment, ECMAScript 6 environment, I'm sorry. You can watch a video on YouTube. I posted the video on YouTube when they explain how to use it. It's quite simple to get started with. As always, it does a lot of magic. Beware of the auto magic things. Try to understand what's happening behind that, because it can bite you, as always. Okay, let's go. That was my digression on JSPM, because I love that project and I don't see people talking enough about that, so I wanted to talk with you about that. Back to Electron. I told you, you can use you can do web development with that. So you can use your beloved tools. On the React Native part, we were seeing how you want to use these tools if you are used to these tools. You don't want to use something else. And you can do that here. You can leverage desktop integration. So you can access with native API to menu, top menu, dock, notification system of the operating system, shortcuts. You can handle multiple display. You can do the focus to a window. You can take the photos. You can put in background. You can do everything you can do with a Cocoa application on Mac or a Windows Presentation Foundation application on Windows. And as I say, you can go down a bit. You can use every single node module that's in NPM. You have the power of NPM in your web application. For example, we use an RPSC server made in Express inside the application. So we have a running HTTPS server inside the application to do to expose some API of our application. We use that to do a tricky thing for social login. So we have a website calling back us with the access token, and it was feasible with half a day of work with everything. It was very good, and you can go down. You can use raw socket. We use raw socket, node socket to push data to our streaming server. That's something very good, and you can get more from Chromium. Chromium or Google Chrome has a lot of command line switches to enable functionality, and as a web developer, you can't expect them to be activated. You have to wait for the Chrome team to activate them. For example, the Harmony flag to have ECMAScript say 6 enabled by default. You can do here. Here you can do it. You control it. For example, we had a problem with a new version of the Chromium. They did something. They changed something on the process priority of Chromium tabs, and when the app went out of focus, it deprioritized the process, and we had problem mixing the audio. We had missing packets on the mixer. But we could use disable render background flag. We pass them, and it solves our problem. If something like that happened in the browser, you can't do anything about that. And here I posted 2 links where you can find all the command line switches of Chromium and some special command line that was added by the Electron team. That it's useful. Or you can go deeper, like we did. You can use Node, so you can build native modules. In our application, we have a C library, a C mixer, and actually we are doing audio processing on the mixer, and we expose the native library to JavaScript via Node.js add-on. And the thing that you have to keep in mind is that Node, Electron, and it's like the front-end word. It's the front-end word of the back-end word, so it's moving fast, blazing fast, and try to use tools to support the new version. So if you want to write a native binding, use NAM. There is a set of macros that help you abstract some V8 internal that are changing a lot. Dynamic libs can give you headaches. Be careful when you are importing native modules that has dependencies from native libraries, DLL or dynamic libraries on Mac OS X. because you have to know how it works, the loading, how it searches on the path. It may work on your machine, but you have to understand what happens when you put the packet in a vanilla environment. Try always that, because the first time is not going to work, I can assure you. And you can do something very cool. You can unit test inside the Electron environment. When you're building a product, you want to do unit test. And not only unit test, integration test, smoke test, and you want to do it in an environment that is the closest possible to the real environment. And so I wrote a launcher for Karma. I don't know how many of you knows Karma as a test launcher. I wrote a simple launcher that you can use to run your unit tests inside Electron, so you can access Node API and you can test everything. It's not. I see that a lot of people push the idea of running unit tests outside the environment, like on Node. But with applications like that use a lot of the hardware, it's good to be inside the real environment, because it may be something different, and that's the kind of bug that hurts a lot, because it's difficult to spot. So why is better than Node WebKit? I was talking about that. You have a lot of facilitation, a lot of things. You have out updates out of the box. It's actually based on two frameworks: Squirrel for Mac and Squirrel for Windows. And setting up just a web service that respond to a call from the application. You can say, oh, here is the last version, and the framework is gonna by himself is gonna download it, check the signature. You have to build a signed up to not to open this mechanism to man in the middle problems. You know, you're sending software to a machine, and it's gonna unpack it, it's gonna check the validity of the files, and it's gonna tell you with a notification that everything went fine and you can reboot your application and you have the new one. Doing something like that, roll your own solution for something like that is difficult. It's not something easy, and it's out of the box here. You have native crash reports functionality that are really easy to collect. You can have all kind of problems that are not directly related to your JavaScript code, but that can happen, like when you have the set phase on Chrome. You can just set up an entry point, and the application is gonna do a post on that entry point with as more data as it can gather about the system. And you can add more if you want. The memory dump are submitted along with the crash report, and they're not so easy to decode because you have to save the bug symbols for every build you make, and you have to desymbolize back the dump you receive from the server. But you can do it. It requires a little bit of experience with the command line, and not more than that. But it's not only this is not the only kind of crash that can happen on your application. You have to keep in mind something about desktop app. I don't know how many of you are doing that, but given 2 operating systems, given 10 versions to support, a lot of different hardware, a lot of USB devices that you can attach on your desktop, infinite trash software that the user will install on their machine, like antivirus. Your app will always fail. Your app will always be in a failing state, in some sort of failing state. You just have to act accordingly. So you want to gather as much information as possible on the host machine when the problem is happening. you want to